Hi, welcome to Sachin Study Tech. Today topic is graph coloring problem. So this is the another application of backtracking. Now we can solve this graph coloring problem by using backtracking technique. So here you can see no two adjacent vertices have the same color. So this is the bounding function. And here it is, if d is the degree of the given graph, then it can be colored with d plus 1 colors. So what is meant by chromatic number? Chromatic number is the minimum number of colors needed to color a graph is called a chromatic number. For example, I am consider this is a graph. So this is a graph. So how many minimum number of colors is required here? You can see this graph. For example, here I am taking one color. Here you cannot take one color, here also, because B, C, D are adjacent of A, so you cannot take the same color. So I am taking 2 here, so you cannot take 2 here because B, C are adjacent. Now you can take 2 here. Then here you cannot take 2 and 1, so you can take 3. So the minimum colors required in this graph is 3. Now for example, here it is. For example, in this graph you can see how many minimum colors are required. For example, this is a graph. So here I am taking one color, so you cannot take 1 and 1 here. So you cannot take B, C, E, R 1. That's why here you can take, here it is 2. So here you can take D because A, D are not adjacent. So here it is 2. So you cannot take 2 here. So you can take 2 here. And here you cannot take 1 and 2. So here you can take 3. So here also you can require the 3 colors. For example, this is a simple algorithm like graph coloring. Now we can discuss. Here you can see planar graph definition. A planar graph is a graph that can be drawn on a plane without any edge crossing. So for example, what is meant by planar graph here? For example, this is A and B, C and D here. This is a graph. So it is a planar graph. For example, you can take another edge also. So here edge crossing here. Any edge crossing. So edge crossing is there. So this is converted into planar graph. Now you can see. Here it is C and D. So you can take any one, either A to D or C to B directly here. I am taking A to D. So here C to B link is here I am taking. So this is a planar graph. Any planar graph, here the 4 color theorem says that any planar graph can be colored using at most 4 colors such that no two adjacent vertices have the same color. So here you can see at most 4 colors is required. Any planar graph, this is a planar graph. So at most 4 colors is required. You can see how many colors. So here I am taking one color. Here I cannot take C, D, B, I cannot take 1. So I am taking here it is 2. So you cannot take 2 and 1 here. You can take 3 here. So here you can see you cannot take 2, 1, 3. So you can take 4. So 4 colors is required. Maybe in some graphs at most 4 colors is required. Either 2 colors or 3 colors, like that. Any planar graph. For example, you can see here it is. Here vertex A, here vertex B, vertex C, here vertex D, here vertex E. For example, you can see this. Is it a planar graph or not? Is it possible to planar graph? Here it is. So you can see here it is not a planar graph. You cannot convert it into planar graph, this graph. So it cannot require the 4, maybe more than 4 colors is required. You can see it is not a planar graph. You can see, for example, I am taking one color here. You cannot take 1 and 1 here. So I am taking here, it is second color. So here you cannot take 1 and 2. So I am taking third color, 3 colors here. So here you cannot take 1 and 3. So you can take the fourth color here. So here you can see you cannot take fourth color, second color, and one color and 3 color. So you can take the 5 colors. So any graph is required 5 color. It is not a planar graph. So it require more than 4 colors. So if any graph is converted into a planar graph, then it can require at most 4 colors. So this is a planar graph. Now we can discuss one example, one simple example. For example, here it is vertex A, vertex B, vertex C, vertex D. This is a graph. So how many minimum number of colors is required? Here you can see chromatic number, how many minimum number of colors is required. So 2 colors is required. For example, I am taking one color here. You cannot take 1. Here it is 2. So here it is 1. Here it is 2. So 2 colors is required. So but I am taking here, it is m equal to red, green, blue. 3 colors I am consider. That is here the d plus 1. The degree of A is 2. Any degree is 2. So 2 plus 1. That is 3 colors I am consider. So how many ways to color this graph? Here you can see. And also one more important point. For example, here any graph is there. So this is the graph. So for example, this is a graph. This area is 1. Here it is 2. Here you can named as 3 and 4 and 5. So here it is difficult to paint that colors in this. So this map is converted into graph. Here there are 5 vertices is there, 1 and 2 and 3 and 4 and 5. So you can see what are the edges. 1 is the adjacent is 2. So 1 to 2, and 1 is also adjacent of 5. So 1 to 5 you can one edge, and 2 is adjacent of 1, 5, 3. 2 is adjacent of 1, and you can see 1, 3 and 5, and 3 is adjacent of 4, 5, 2. 3 is adjacent of 4, 5, 2, and 4 is adjacent of 5 and 3. 4 is adjacent of 5 and 3. 3 already there. So 5. So now you can see here there is no edge 2 to 4. So this is a graph. So you can color the graph here. How many minimum number of colors is required? Here you can see. So for example, I am taking one color here. So I am taking, cannot take the 1 here, cannot take the 1. So I am taking here, it is 1. So here also I am taking 1. Sorry, here it is, you can take the 2 because it is adjacent. Here also cannot take 1 and 2. Okay, I am taking 3. So here you can see, here you can see, here it is, I am not taking 1. So I am consider 2. So minimum 3 colors is required. So now we can solve this problem, graph coloring problem. So if any map is given, then the map is converted into graph, then color that graph. So how many ways to color this graph? Here it is. Here it is root node. For example, A is colored red color. Only 3 colors is there. So for example, here it is root node. A is colored red color, A is green color, A is blue color. So here you can expand. This is a state space tree. You can find out all possible solutions. Now here it is, either B take red, green and blue. Here you can see, here you can take the red color. A is red color, B is red color. You cannot take the red and red, so violate the bounding function. So you can close this one. You cannot explore. If you can explore this one, also cannot find out the solution. Then here you can consider the B is green, so no problem. Then you can expand. Here it is, so here it is C equal to red, green, blue. If C can take red, here red is violated the bounding function, and also C can take the green, so no problem, you can take the green here. You can expand this. D equal to red, green, blue, so you can take D equal to red, no problem, you can take. Here it is the one solution, here one solution. For example, I am taking D equal to green, so green is violated, so it is not a solution. So for example, I am taking D equal to blue, S, this is also another solution. Now you can see, here it is C equal to blue, C equal to blue. You can draw the one more diagram. Here it is C and D. So for example, C equal to blue, here it is A equal to red, B equal to green, A equal to red, B equal to green. Then C equal to blue, C equal to blue. Here you can expand this. D equal to red, D equal to green, D equal to blue. So for example, you can consider D equal to red. Okay, no problem, you can take. So here also another solution. So for example, D equal to green, D equal to green, you cannot take, so it is not a solution. For example, you can take D equal to blue, D equal to blue, so here the blue, so it is also not a solution. Now we can expand this one. So for example, A equal to red, for example, here it is, you can draw the all possible solutions. So for example, A equal to red, A equal to red, and B equal to blue, B equal to blue. Here you can expand this. Now C equal to red, green, blue. Here C equal to red, for example, you can take the red, it is violate the condition. So C equal to green, C equal to green, you can take C equal to green, so you can expand this. D equal to red, green, blue. For example, I am taking the D equal to red, so no problem, we can take it. So it is a one solution. So if we can take green, so it is violate the condition. So you can take the blue, here also violate the condition. Now here you can see A equal to red, B equal to blue, B equal to blue, and C equal to blue, C equal to blue. So you can take the blue here, C equal to blue. You can expand this. D equal to red, green, blue. So for example, you can take the D equal to red here, D equal to red, no problem, you can take it. So it is blue, C equal to blue, A equal to red. So here you can see B equal to blue and C equal to blue. So B equal to blue and C equal to blue, no problem, it is not adjacent. That's why you can take, here it is D equal to red, D equal to red, you can take. This is another solution. For example, D equal to G green, so you can take the green. So this is another solution. Like here it is. For example, you can take D equal to blue. So D equal to blue. So that is violate the condition. So these are the possible solutions. So you can note down, here it is solutions. You can note down in this tree what are the solutions is there. A equal to red, R G R G G R R G G R R G G R, and another solution is R G G B R G G B. This is another solution. You can see R G B R R G B R. This is another solution. Here you can see, here it is the solution. R B R R B G R R B G R. This is another solution. Here you can see R B B R R B B R. This is another solution. So you can see R B B G R B B G. This is also another solution. You can see how many solutions: 2, 3, 4, 5, 6 solutions, up to this 6 solutions. So you can erase this. Now you can expand this one. You can expand this one. Here it is. How many solutions is there? For example, I am taking A equal to green. For example, I am taking A equal to green. Then, for example, here it is. I am considering here example. Here it is. Now A equal to green. Then A equal to green. You can see. So B equal to red, green, blue. So you can take B equal to red. No problem. You can take. Here it is. You can expand this. C equal to red, green, blue. C equal to red. You can take the red. So no problem. So you can expand this. D equal to red, green, blue. So you can take the D equal to red. So violate the rule. So you can take the D equal to green. So you can take D equal to green. So this is another solution. So better you can note down GR, GR, RG, GR, RG. And also you can see here it is D equal to B, D equal to blue. This is another solution. So GR, RB. This is another solution. Now you can see here it is C equal to green. So that is A equal to green, A equal to green, B equal to red, B equal to red, and C equal to green, C equal to green. You cannot expand this. C equal to green. So C equal to blue. Here you can see C equal to blue. You can expand this. So here it is D equal to red, green, blue. So I am consider D equal to red. So it violates the condition. So I am taking D equal to green. So this is another solution, that is GRBG, GRBG, that is another solution. Now you can see here it is GRBB. So here it can see, you can take blue here, so it violates the condition, so it is not a solutions. So these are the solutions is there here. Now you can see, you can expand this one. Now you can expand this one. Here it is. For example, here it is. You can expand this one. Here A equal to green, A equal to green, B equal to, for example, B equal to green, B equal to green. So green green it violates. So A equal to green, A equal to green, it is blue. So I am considering it is blue. So you can expand this. C equal to red green blue, red green blue. So here it is C equal to, I am considered red. So you can take C equal to red. You can expand this. D equal to red green blue. So I am taking D is red. So red it is violates the condition. So here it is green, D equal to green. So you can take green. You can take green here. This is another solution. So that is GBR, green, blue, red and green. And also you can see it is, I am taking D is blue, taking blue here, blue is violate the condition here. Then it is you can expand this. G, here it is A is G, A is G, and B equal to blue, B equal to blue here, and C equal to green, C equal to now green. So green it violates the condition, green. So here it is C equal to blue. I am taking blue here. I am taking blue, green, blue. Okay. Then you can expand. Here it is D equal to red, green, blue. So I am taking D equal to red. So I am taking, here it is C equal to blue. Here green, here blue. So I am taking red here. You can take. This is one solution. That solution is green, blue, red, green, blue, red. You can consider here it is another solution. For example, I am taking D equal to G. So you can take red or green. Here it is a blue. So you can take here G, B and green also you can take. This is another solution. For example, you take blue. So blue it can violate the condition. So here there is no solution. This, so like that here also you can expand. Here also you can expand here. This is the number of solutions we have to find out. Here have to expand here. So you can see here it is. So for example, B equal to, so I am drawing one more diagram. Here it is. For example, these are the all possible solutions. Like that, you have to find what are the possible solutions is there. Have to find out by using backtracking here. B equal to red, green, blue. So I am taking A equal to blue. Here it is A equal to blue. Then B equal to red. You can take B equal to red. You can explore this. That is C equal to red, green, blue. C equal to red. You can take the red. So here you can expand this. D equal to red, green, blue. So D can take red. So it is violates the condition. Red, red. Here also red. So here you can take D equal to green. This is the solution. So note down what is the solution here. It is blue, red, C is red, C is red, and D is green. This is solution. Now you can see, for example, D equal to blue, D equal to blue. This is also a solution. This is also a solution. That is blue, red, red, blue. This is also a solution. Now here you can expand this. For example, C equal to green. So A equal to blue, A equal to blue, and B equal to red, and C equal to green here. C equal to, for example, here I am taking green color. Now you can expand this. What is the D color here? It is D is red, green, blue. D equal to I am consider red, so it violates the condition here. Red, red. So I am taking green. Here also violate the rule. Here you can take the D equal to blue. Here you can take blue. So that is blue, red, green, blue, blue, red, green, blue. So this is also another solution. Now you can expand this. A equal to blue, B equal to red, and C equal to blue here. C equal to blue. So blue can violate the condition here. Now you can see here it is you can see the next possibility. So here it is A equal to blue, A equal to blue, and B equal to green, B equal to green here, and C equal to red, green, blue. So for example, I am taking red here. So you can expand this one. Either D equal to red, green, blue. So I am consider D equal to red. It violates the condition here. Red, red. So here I am consider it is green. Here also violate the condition. Here I am consider the blue. So you can take the blue. This is the solution here. It is a solution. So it is blue, green, red, blue, blue, green, red, and blue. This is another solution. Now we can expand this one. So A equal to blue, A equal to blue, and B equal to green, and C equal to green. Now we can take C equal to green here. You can expand this one, and D equal to red, green, blue. So I am taking D equal to red. You can take it. This is also another solution. That is blue, green, green, red, blue, green, green, red, BGGR. Now you can see here it is. For example, I am taking D is green, so it violates the rule here. I am taking blue here. You can take the blue. So here it is blue, green, green, blue. So this is also another solution. Now we can expand this. C equal to blue here. For example, A equal to blue, and B equal to green, and C equal to blue, and here it is blue, blue. So cannot take. It is not a solution. Now we can expand this one. Here it is. You can expand this one. Here it is. A is blue, B is blue. So A is blue and B is blue. So it is not a solution. So these are the number of possibilities. These are the number of possibilities For example, you can take 3 colors, 4 vertices. These are the